Okay, so smart syncing is a very sophisticated and simple to use tool. Basically, what it is you can take a skeleton model or any other piece of geometry within your Creo assembly and use it as basically a 3D measuring stick to design your product. So I've got this skeleton here of this cylinder assembly, and as you look at it here, you'll notice that it's got a series of sketches, and it's just a 2D planar design. The neat thing about this is that it does have things designed based on desired goals for the design. So this is something that's a little bit unique about how this works. But if you come to your relations file here, you'll notice that we've got this set up to receive some parameters for the input values. For example, this internal diameter here is driving this particular dimension. The piston thickness and all these other things are also, important components of the fundamental design. But things like the offsets aren't being computed in a spreadsheet or within Creo. They're kind of resultants. So we actually are using let me cancel this and I'll show you a little bit closer here. We're actually using a reference dimension to pick up what the final diameter of this is relative to a desired offset thickness that is like an industry standard or a spec-driven design or best practice. So what we're doing is we're actually designing the structure of this based on known offset requirements and producibility requirements, and then we're going to let the rest of the design kind of figure out what it is. So if I come back to my relations here, you'll notice that I'm collecting data at the first part, and then the SmartSync basically uses these parameters to pass information to targeted models. So the first part of this is the name of the model that it's going to go to, and there's a double underscore. And then the second part is the parameter that it's going to be sending the data to. So this parameter that's set in the skeleton is actually pulling data from the design for what the final dimension should be to pass to that particular model it's associated with. So you can see we have tube dimensions that are going to be smart synced, piston dimensions they're going to smart synced, and shaft dimensions they're going to be smart synced based on the fundamental design inputs into the design. So we're going to go back to our spreadsheet here, and I'm going to first set a parameter value to that skeleton model. So it's cylinder skel.prt and internal diameter, and we're going to set this to like 200 millimeters. Now, to synchronize the data, the only thing you need to do to get all of that stuff to pass around is we need to put in a regenerate for the model, and we're going to just come down and say regenerate, regenerate. And then we're going to come in and we're going to say smart sync. So that's a model function. And we're going to go all the way down to the bottom and say smart sync. And we're going to smart sync that same cylinder part that we were just working with. We actually have to spell it right. Okay, so, and then we'll do another regenerate. So I'm just going to copy and paste what's already there. When we run this, you'll notice that not only does it pass the data to the skeleton model and adjust it with the regenerate, but then it does a smart sync of all of the components that are affected by the changes to that skeleton model so that they can be updated also. What's the net effect of that? Well, basically, this particular part that you're looking at here is completely parameterized, but it's also completely independent of the knowledge that generated it. So there's no reference to the skeleton, and there's no reference to what produced these final dimensions. And all of the parts in the design follow that same methodology and process.